All right, so we are gonna we are creating our piping system type, our pipe type. So um, what we've done is we're setting the routing preferences. This is where we pick the type of pipe that we're using for the different pipe segments. So just for a pipe segment, I am setting sanitary to polyvinyl chloride, rigid schedule 40. I'm going to set my minimum size. I'm going to set it at ½ inch just for the hell of it. Um, I'll never use that size, but that's what I'm going to do. Okay. And then for my elbows, as you can see, I have a lot of different families loaded into this project, but I'm going to set this to a bend, PVC bend schedule 40, drain, waste, and vent. That's what DWV means. Of course, all of you know that. Preferred junction type. Now, hopefully you guys know what this means, but typically piping, sanitary piping or domestic water piping, the way that things will cross each other is in a T formation. Um, and we're going to set our junction type to a, you have to kind of think about this a little bit. How do you want sanitary piping to cross each other? Um, you might want to use this combination Y and eighth bend, which is more realistic. But in reality, when you're actually doing your pipe routing, that family doesn't really deal well with sloping. At least it didn't in Revit 2010, 11, 12. And now that I'm working in 14 now, it may actually work better, but I just feel a little bit more comfortable dealing with the reducing sanitary T. And then if I need to, I can change it to the combination Y and 1/8 bend later. Um, cross, same deal. I will uh, I will set this as my reducing double sanitary T. And the reason I don't use just a double sanitary T is just because you don't have the flexibility that you do with the reducing double sanitary T. And a little bit of this decision making was experience with dealing with the older versions of Revit. And like I said before, 2014 is probably a little bit better at dealing with the Y 1/8 bend. But I've even found in projects where I really was using the Y 1/8 bend exclusively, I was better off choosing these two junction types as the reducing double sanitary T, just because it was a little bit more flexible. So that's what I'm going to set that on, and maybe we'll run into an example later where you can see that. But reducer will set that to a PVC schedule 40 drain waste and vent union, self-explanatory. And so there we have our piping system set up. We're calling it sanitary waste for a screencast. Now you could give it other identity data, but I'm not going to mess with that right now. You could give it cost, but later on another screencast will show you why this cost number without a formula kind of is um, kind of a misnomer and misleading. So we're going to start our piping system. You choose which one you want to start with, and I'm going to set this to that pipe type we just created. And I'm going to just draw this down to an arbitrary. I'm going to set my sloping down because we want to actually turn from the water closet and go down. And as you can see, I've got my slope at 1/8 inch. And now I might even move that pipe up just a little bit. Actually, you can't see the slab right now. Let's get that in. It's actually shown, but I don't know why. I don't know where it is. Maybe the architect didn't show it. Again, this is a faulty model. It's not perfect, but this is just to show you how to create basic piping systems in Revit. So you may, uh, let me just preface the rest that I'm going to do with this piping system with this statement that with a well-developed family library, your creation of these systems and the routing and all that stuff may be a little bit more dependent on the family that you've actually created. Um, you may want to actually have a family that has all of this stuff built in already down to a certain point. Let's say that we know that our slab is 6 inches deep or 4 inches deep, however, whatever it is. You would want this rollout to be just a little bit below the slab, and it would roll out to your 1/8 inch slope pipe over to this, what this would actually be, because we have back-to-back fixtures, this would actually be that Y and 1/8 bend. So what I'm going to do is I'm going to extend this out a little bit because I know that that Y and 1/8 bend actually takes up a good bit of space. So I'm going to select that, and I'm actually going to go and actually choose the Y and 1/8 bend. So now you see that it has changed that fitting for me. And now you see if I select the fitting again, I have a plus on the other side. What did I do wrong here? Okay, this needs to be a Y and 1/8 bend double. Let me load that. I'll load the family, pipes, fittings, PVC, schedule 40 socket type, oh, drain, waste, and vent, and then we'll go back to our, see now what happened is I didn't actually have that family loaded. So I'm going to go ahead and load the, I'm going to load the Y and one, combination Y 1/8 bend double. And that's loaded into the family. See, it wants me to place it somewhere, but I'm actually going to select the fitting that I already had there, and I'm going to change that to a double. Now we've got what we're looking for. Okay, now I can actually, I'm going to work backwards this way. So with this fixture, I drew from the fixture connector, and I drew over to my fixture stack. But with this one, I'm going to draw in the opposite direction so that I can keep my sloping consistent. I'm going to start drawing the pipe. What I did, if you're not aware of this, is I select the fitting, right click on where I want to actually draw the pipe, and I'm going to draw, and I'm going to select my slope to be up. And what it should do is give you this little dotted line to show you that it's in line with the connector, but sometimes it's buggy and I don't like dealing with it. So I'll just draw it slightly down, and then I will actually start my other section from the fixture itself and then trim these. And there we go. We've got a perfect set of back-to-back water closets started with a sanitary system. And now when this pipe comes up above the slab, it's going to transition to a vent. And then this is what I was talking about when I mentioned having a well-developed family library. You may actually want all of this stuff that you see in your family library so that you have a set of back-to-back fixtures already in place that have all this done. And the reason I found that somewhat problematic, especially with water closets, is that um, the chase space may actually be different. The architect may not have given you the same space size as he did on the project that you did with him before. So I found that it's actually more beneficial for me to just do this method that I'm going to show now. So now how do I actually split this system? So what you see now um, is that I have a sanitary system started. So if I select the pipe and I go to the top ribbon, there's a tab called Piping Systems. And if I select the piping systems, I can go here and I can see that that system name is called Sanitary 1. Now, we all, as MEP engineers, we have our own nomenclature for the systems that we have in our projects. And sanitary, or I'm sorry, plumbing piping systems can go by various names. Here's where you can actually go and you can change the name of that system. What I typically use on my projects is I'll use SAN for, and actually is already in use. let me. Here's how you manage your piping systems is through the system browser, and I'm actually going to pull this over and tab it with everything else. I am going to, just for the screencast, so I can get through this, I'm going to delete SAN. I'm not actually sure why it's there. I thought I deleted all the piping. So I'm going to select this piping. Now there's two ways that you can edit the system name. The one that I started to show you was go up to the ribbon and hit that piping systems tab, and then go to your properties uh, properties panel, and then change the name there under system name, and then apply, and there you go. Now you have a SAN system. And this means a lot later. I'll show you when we get into filters and stuff like that for your piping systems. But for now, just know that I've changed that system name now to SAN. And just as an example of what that does for you is I've created a tag. Well, actually, I do want a leader, but I want a free end. Created a tag that will tag that pipe with the size and the system name. And just quickly on how you do that. Edit that family, go and select the label, edit the label, and you can see here I've chosen from a list of um, a list of parameters that are available to pipes, and I've chosen size and system name, and I keep them in line with each other with one space in between the size and the system name. And so that's what's important about uh, labeling your piping systems a certain way. If you kept it the default value, which was sanitary 1, because it was the first sanitary system in that's what my tag is going to show. You may not want to use these tags, but this is the way I prefer to document Revit models. Anyway, so that's how you basically create your pipe type and your piping system. So there is more to it, and just quickly I'm going to show you um, what is involved with an actual pipe system. I'm going to go to my system, or I'm sorry, I'm going to go to my project browser here, and I'm going to go actually look at my pipe systems. So this is different from the pipe types. We have our pipe types up here, and we have our systems here. And what is different about these? Um, these actually These have to do with the actual fluids that are flowing through your pipes, and it affects the calculation values in Revit. So I'm not exactly sure what the defaults are. I think that the defaults include most of this stuff here. I've added natural gas. What else did I add? I added filter water to this. This had something to do with being a template from another project. But if I were to right click on sanitary piping system and then go look at the type properties for that system, um, you can see that there's a couple of things that you can change here. Um, for sanitary, there's not a lot that you can do except for change your calculation types, and I'm actually going to set this to flow, and we'll get into how that works later. But you can change how your rise and drops look graphically. But I uh, I am actually trying to move out of the old school version of engineering documentation and into what I think is the new way to really show piping in a engineering document where I'm not actually using these symbols anymore. I'm using what you see here. Um, and I hope to actually kind of convince you that this looks a little better, um, but we'll get into that later. If I were to actually go and look at the domestic water system, if I go and check the pipe properties, you can see there's a couple more values here that you can affect, and you get your fluid type. You can change it to a bunch of different stuff here, and these are actually customizable as well. You can set your fluid temperature. This you're also when you go and you manage your fluid types and properties, you can set the viscosity, density, things like that. Um, we actually do want to set this value in our projects. If you have a predominantly flush valve project, which is the most stringent flow conversion method, if you have any flush valve fixtures in your project, or at least, like this project, we have 2 or 3 flush valve fixtures versus the other just standard fixtures. We're going to pick flush valves as our predominant flow conversion method. So you can see that there's a couple of more values that you can change here than you could on the sanitary. Sanitary is pretty limited. And just quickly, how do you manage those settings? You would have to go to your Manage tab, and then you would then go to your MEP settings, which actually are hidden because my screen's so small. Go to Mechanical Settings and go to your fluids, and here you can see there's all those fluids, and you can change these things. I'm not going to mess with that right now. We'll get into that more when we start actually using Revit to do some sizing. Just wanted to give you an idea of like this. This is all of what piping systems are about, and there's a lot that you can actually do. So back to where we were. How do we actually split the sanitary system from the vent system? Um, Again, there's a couple of methods. One of them is having a very well-developed family library, and then having those connectors built to the library so that they are actually different. But when the architect changes this chase size on you, it's hard to really keep a consistent family like that. And there's a couple of ideas I've been throwing around, and I'll show you this on other screencasts as a better way, I think, to deal with these. But just quickly, I'll kind of give you a glimpse of what that's going to look like. I'm going to select this family. I'm actually going to select all of this. I'm selecting everything because I am very confident with this filter uh, feature of Revit. I don't want to select the connector element. I want everything except for the connector element. And there's this visibility setting. If you go to your properties panel after selecting those things, what I'm getting at is I want to hide the fixture itself because I may want this to become part of my standard library, but I don't want it to look different from what the architect has. But at the same time, I want to use my standard library families and keep my connectors and all the stuff the same that I'd already used. So I can select all of that stuff and go check this visible thing. And I'm actually going to add a parameter here, a type parameter. This is important. If I were to select instance, it would mean that that particular instance of this family in the project would have the settings I gave this parameter. So what I'm going to do is I'm going to set it to type. I'm going to call it show plumbing fixture, and you can name it anything you want to, but I want to put that under the category of visibility. And so now all of this stuff is associated with this parameter called show plumbing fixture. And if it's checked, it means it's visible. So I'm going to load this back in. And now this is a point where it's very important to overwrite the existing version and its parameter values. Now I'm going to select this fixture. I'm going to edit the type, and I'm going to go down to that value, show plumbing fixture, uncheck it, and now that fixture shouldn't show up. And something's funky going on here, but this is the way it should work. I go to, well, it's still showing up, but you get the idea. There may be some stuff in the family. When that happens, typically there's some embedded objects in this family that have to be fixed. probably need to explode. So I'm going to uncheck that. Yeah, I can't even explode that. Check that. Yeah, I'm not exactly sure what's going on with this. Um, anyway, okay, I don't want to waste your time with this, but the point was that you could actually build a family library where the fixture itself was not visible. Um, only the piping that you had created for that family was visible. But anyway, the next point of creating the sanitary system was how do you actually separate the sanitary piping system from the vent piping system? Because as we know, the sanitary and vent piping systems are connected inherently. So how do we actually separate this? Well, what I've created for these custom type setups like this was a family that could be used as a connector type, fake dummy type fitting. And I called this a universal connector because it is capable of taking on properties of any kind of system. But um, I'm just going to edit this family so I can show you what it looks like. Um, Basically, that's all it is. It's an extrusion with fittings, or I'm sorry, connectors on each side that, as you can see in my properties panel, the bottom connector is called system classification sanitary. I don't worry about any of this information because I'm not actually I'm not really doing anything as far as fixture units and stuff from this connector because you'll see where it's placed. It doesn't really make any sense to do that. The top connector is called vent, and that is actually already loaded into my project. So what I'm going to do is I'm going to insert that here on top of the fixture stack. And where it defaults to is offset at 0, 0. I'm actually going to set that at 3 inches above the floor. And there it is. And then I'm going to set its nominal diameter. Now this, I'll show you how to get into affecting the dimensions. There's a better way of dealing with this than the way I've done this. But just for the screencast, just so that I can show you how to separate the systems for now, I'm just going to use this family as it is. So now that's set. Now I'm going to go back and look at my elevation view, and you can see where that family came into place. So see, it's 3 inches above the floor. It's directly centered over this fixture stack, so I should be able to connect this pipe to it. I'm just going to drag it up there. And now if I select that, you can see that it's actually been put on that system. Did I not rename this? All right, I need to rename this back to what I wanted it to be. San. If I select that family, you can see it's still San. Now, with that family selected, you can see that I have two different types of connector options here that I can draw a pipe from. One is sanitary, and it's grayed out because it's already connected, but I have the vent that is not connected. So I'm going to select that to draw a pipe from it. And you can see that it's set on a pipe type, the last pipe type that I drew from. As I draw it, I'm going to go ahead and set this to the sanitary vent pipe type that I'd already created, and the system type should be vent. So I'm going to draw this up into the ceiling space, and I'm going to go ahead and pull it out a little bit, sloping up. Again, you want your vent piping to slope it at 1/8 inch. And there you go. So now we've got two separate systems that visually look like they're connected to each other unless you get in really close here. But that's it. That's how you separate those systems. That's one way. There's probably better methods, but this is the method that I have used for a while that I think works fairly well for me. And you would think that this seems a little bit complicated and takes a lot of time to do, but as you get used to using Revit, you're more fluent with the controls and using the different views. it actually becomes a little bit more simple. And in fact, if I wanted to, oops, I didn't mean to grab that. If I wanted to, I can grab all of that pipe, including that connector, and go back to this view. And I don't want this side, but I'm not going to worry about that right now. And I'm actually going to copy that down. And you can see it will automatically try to align with the reference line that was given in this water closet. So basically, I did that once, and now, sometimes it's hard to select the fittings. I did that once, and I can actually copy it down and use it for the next set of fixtures. But as you can see, I deleted the other side of that Y fitting, so now I've got just um, this reducing sanitary T, which I actually don't want. I want to set this again to my Y 1/8 bend. And there you go. We've begun routing our sanitary. So now, just really quickly, I'm just going to route this out a little bit and just give a realistic real interpretation, or I mean version of what the system should look like. I'm going to draw the pipe down from that, and I'm going to actually slope down now. I'm going to draw it off a little bit here. And see how it automatically tried to connect that, which is fine. Really, actually don't want that. That is not per code. So we're going to change this back to that T reducing sanitary. And this should be the combination Y 1/8 bend. Now we have a more realistic looking system. And then continue that pipe. Continue it out to, actually, want to make sure I go ahead and have that 45 set in this so that we're, like I showed you at the beginning of this screencast, how that separation of pipe and drawing in a different direction can kind of mess with your invert a little bit, or your sloping. Then I'm going to go ahead and draw some pipe up this way. Oops, I don't want to go up. You get that warning because I was drawing pipe down instead of up. I want to draw up because I'm going to a clean out. And then I'm going to set my offset at 0 so that the pipe's even with the floor. And I actually don't have that in here yet. I'm just going to set it 0 and hit apply. And there you go. Now you saw before that I drew that vent and actually had it coming out away from the fixture stack somewhat, or the vent stack. But you don't see it here, so where'd it go and why don't you see it? It's because our view range hasn't been set to where we can see it. I know it's probably up above 12 or 13 feet, so I'm going to go ahead and set my top range at 13 feet, and there's that pipe. Now here's where there's a little bit of a decision making that needs to be made as far as how you're going to actually document and what's the difference between modeling and documenting. And I actually like to maintain a little bit of that schematic type of setup for documentation rather than going completely realistic always. But that can be a preference, and it also could have a lot to do with the project you're actually working on. For this project, I actually do want to be as realistic as I possibly can. So this vent piping would actually realistically just sit on top of the sanitary pipe, but up, in the ceiling space. May even actually be down low in the chase. But as you can see, I'm gonna go ahead and draw out to a vent through roof. Draw pipe, We're sloping up at this point, and then I'm going to draw this up to, I'm going to say, I'm not sure where the roof is, but I'm just going to give it an arbitrary value. And there you go. Now if I were to come back and tag this with, actually I don't want it at eighth, I'll go to quarter. If I were to go back and tag this stuff, you can see that, there's sanitary, there's my vent, and I haven't given this the proper name yet. I'm going to go back to my vent. I like to call vent V, 3-inch V, 3-inch sanitary. And there you go. That's the beginning of a piping system that's sanitary, split away from your vent system. And documenting this, you wouldn't even, you would see this. It's somewhat, I mean, it works for our purposes. But as you can see, that visibility values taking place right there. I can't see the plumbing fixture. And there you go. The next screencast, I will go into more depth on this. We'll cover the domestic water system, and there's some interesting things to do with your fluids and stuff like that. But hope at least that one little tip on doing the universal connector helped everyone, or gave someone a good start on this kind of stuff. And again, like I said, having a well-developed family library can help circumvent a lot of these little weird tricks that you have to use. But under a crunch, this actually works pretty well, and this is what I've been using for a while. The companies I've been working with haven't really had the time to develop libraries that extensively that we've actually been able to draw these connectors into everything. As a lot of companies are, we're probably playing catch up for the most part because architects have been using this software for quite a while, but MEP engineers really haven't, especially smaller companies. So I hope that through these screencasts I can give you a couple little tips like this here and there that will help you catch up pretty quickly. And um, what I hope to cover in these screencast series is how to actually draw this stuff, how to actually model these systems, and show you all the little tips and tricks that I've found along the way. And then um, in the end, we're going to actually have a fully designed model and a fully documented set of drawings. And in the future, I will actually include uh, the files for this stuff, and you'll be able to download them for your use and follow along with me. Um, but I hope that helped, and I hope that you guys come back, and I hope to really create a good community here, get some feedback from engineers that have been using the software. And if you found things that work better and you're willing to share with everyone, then please feel free to comment, and I would be glad to incorporate those comments in future screencasts. So thanks for checking me out, and I hope you enjoyed it.